From sandstorms on alien planets to galaxies that break the laws of physics, the James Webb Space Telescope isn't just showing us the universe, it's rewriting it. With sharper eyes than any telescope before it, Webb has revealed cosmic secrets we never imagined. Buckle up, because these discoveries will seriously blow your mind. Galaxies that shouldn't exist. Imagine peering back to a time just 500 million years after the Big Bang, when the universe was basically a cosmic newborn, and finding galaxies the size of the Milky Way. That's exactly what James Webb did. Astronomers spotted 6 enormous galaxies filled with mature red stars that shouldn't even exist yet. According to our current theories, galaxies back then should have been small, messy, and still figuring out how to be galaxies. But these, they looked fully grown. Some scientists even called them universe breakers, because their existence defies our understanding of cosmic evolution. It's like seeing skyscrapers in the middle of a medieval village. Something doesn't add up. Are our models wrong? Are these galaxies just glowing weirdly bright? Or is the early universe far more advanced than we ever imagined? One thing's certain, James Webb just opened a new cosmic mystery that scientists are still scrambling to explain. And if ancient galaxies shocked you, wait till you meet the monstrous black holes present right next to them. The most distant black hole ever spotted. Meet Sears 1019, a black hole so ancient, its light has travelled over 13 billion years just to reach us. James Webb spotted this cosmic beast existing only 570 million years after the Big Bang. And it's not small. It's 9 million times the mass of our Sun. How did something that big form so fast? Traditionally, black holes grow slowly, starting from the collapse of a single star feeding over time. But this one, it seems like it skipped the line. Scientists think it might have formed through the direct collapse of massive gas clouds, bypassing the baby steps completely. Even crazier, Webb has since found one even older, just 440 million years post-Big Bang. These discoveries are rewriting how we think black holes come into being. And if these early monsters were already roaming the universe back then, what else might be hiding in that ancient darkness? Now, picture those black holes all connected by invisible threads. Because up next, Webb discovered the cosmic web's oldest strand. A strand of the cosmic web, 830 million years old. You've heard of the internet, right? Now meet the universe's version, the cosmic web. It's a massive structure of gas, galaxies, and dark matter, stretching across the universe like glowing threads. And thanks to James Webb, we've now seen one of its earliest strands, formed just 830 million years after the Big Bang. It's a gassy tendril stretching 3 million light-years long, lined with 10 galaxies and anchored by a powerful quasar. Think of it as a celestial highway that galaxies use to grow, evolve, and even collide. Before this, such a filament had never been seen so far back in time. Its discovery proves that the universe's large-scale structure began forming way earlier than we thought. This wasn't just cosmic spaghetti. It was the backbone of the early universe. And every time we look deeper, Webb keeps adding new pieces to this enormous, invisible puzzle. Speaking of bizarre discoveries, how about pairs of planet-sized objects floating through space with no star in sight? Yeah, it gets weird. The mysterious jumbos. Imagine twin planets the size of Jupiter just casually drifting through space, far from any star. No solar system, no sun. Just 2 big lonely balls of gas, floating together. That's what James Webb found inside the Orion Nebula. 42 pairs of these mysterious objects, now called jumbos, short for Jupiter mass binary objects. They're too small to be stars and too neatly paired to be random. So what are they? Failed stars, rogue planets, something in between? What's even stranger is how they exist in pairs. That's like tossing 2 bowling balls into space and expecting them to stick together. It shouldn't happen. But there they are, side by side, quietly rewriting the rulebook on planet and star formation. Some scientists now think there may be an entirely unknown process creating these jumbos. If true, it means there are things happening in star nurseries that we've never even imagined. And if you think jumbos are strange, let's talk about an exoplanet that might be burping out the smell of life. Signs of life? K218b's potentially biogenic gas. K218b is a super-Earth exoplanet about 120 light-years away. It's larger than our planet, smaller than Neptune, and sits in the Goldilocks zone. Not too hot, not too cold, just right for life. When James Webb zoomed in, it didn't just detect the water vapor, it found methane, carbon dioxide, and something really wild, dimethyl sulfide. Why is that a big deal? Because on Earth, dimethyl sulfide is only produced by living organisms, specifically plankton. If confirmed, this would be the first ever hint of a possible biosignature on another world. Imagine alien microbes floating in an ocean under a hydrogen-rich sky. Of course, NASA scientists are staying cautious, saying we need more data. But it's hard not to dream. A whiff of life on a distant ocean-covered planet just might be within reach. But if ocean worlds weren't exciting enough, let's head somewhere really wild. Planets with actual sand clouds and rock rain. Rock clouds and silicate rains on alien worlds. You've heard of cloudy skies, but what if the clouds were made of crushed rock? That's the case with WASP-107b and WASP-17b, two exoplanets where James Webb detected something downright bizarre: silicate particles, aka sand, in the atmosphere. These gas giants are puffy, with hot, extended atmospheres. On Earth, clouds are made of water droplets, but on these worlds? Vaporized minerals rise, condense into tiny rock crystals, and fall back down as literal stone rain. On WASP-17b, Webb even found quartz crystals. Basically, the planet is glittering with natural glass. This kind of discovery doesn't just sound like fantasy. It changes how we understand atmospheric chemistry and cloud formation across the galaxy. The fact that it's raining hot sand out there somewhere in the cosmos, that's both horrifying and incredible. Coming up next, a glowing ring of cosmic death and a haunting preview of our own star's future. The Ring Nebula's death spiral. In space, even endings can be beautiful. Just take a look at the Ring Nebula, also known as M57. Thousands of years ago, a star like our Sun began to die. As it expanded into a red giant, it puffed off its outer layers. What was left behind was a glowing shell of gas shaped like a cosmic donut, and James Webb captured it in haunting high-res detail. Using infrared, Webb saw the fine structure of this nebula, including hidden clumps and eerie concentric rings outside the main shell, features never seen before. This is more than just a pretty picture. It's a window into what our own Sun might look like in 5 billion years. Earth, it won't make it. But thanks to Webb, we'll have front-row visuals of what happens when a star like ours says its last goodbye. But from dying stars, let's travel to an icy moon, where life might just be hiding beneath the surface, shooting clues straight into space. Enceladus shoots a massive geyser into space. Enceladus is small, just 313 miles across. But what it lacks in size, it makes up for in drama. James Webb recently spotted something spectacular. A massive geyser erupting from the moon's surface, spraying water vapor more than 6,000 miles into space. That's 20 times the moon's own diameter. The source? A subsurface ocean hidden beneath Enceladus' icy crust. What makes this discovery so exciting is what that ocean might contain. Webb's observations suggest it could be rich in carbon compounds, essential ingredients for life. This cryovolcano isn't just venting water. It might be sending out chemical postcards from a hidden world beneath the ice. And if there's organic matter in that spray, it's a huge step toward finding life in our own solar system. But while Enceladus surprises up close, JWST also delivered a jaw-dropping first look at the deepest corners of the universe. The deepest view of the universe, SMACS 0723. This was the image that blew everyone away. Webb's first full-colour deep field of the galaxy cluster, SMACS 0723. It may look like a colourful sprinkle of stars, but it's so much more. Some of the galaxies in this image are over 13 billion light-years away. And thanks to gravitational lensing, Where massive foreground galaxies bend light like a magnifying glass, Webb captured warped, stretched, and mirrored versions of galaxies far beyond. Those faint orange arcs. Duplicated galaxies, their light bent and magnified by the mass of the cluster. This single snapshot contains thousands of galaxies in different stages of evolution, including some from the earliest days of the cosmos. It's like looking into a time machine, one that stares back 97% of the way to the Big Bang. It redefined what deep space photography could be. Now, let's return to something familiar, but seen in a way we've never been able to before. Star birth in the Pillars of Creation. You've probably seen the Pillars of Creation before. Hubble made them famous in 1995. But when James Webb turned its powerful infrared eye on these giant towers of gas and dust, the view changed completely. In this image, the pillars are no longer just silhouettes. They're glowing, alive with newborn stars and dense knots where stars are still forming. You can even see jets of gas being blasted out by young stars inside these dusty towers. Each pillar is about 4 light-years long, nearly the distance from Earth to our nearest star. Webb's ability to see through the dust reveals what Hubble could only guess. These are star nurseries in action, and watching them is like seeing the universe give birth. It's breathtaking and humbling. And speaking of stars, how about the first ever real photograph of a planet orbiting one of them, taken from light years away? Direct image of exoplanet HIP 65426b, Narsicapaic. This is HIP 65426b, or as it was officially named in 2022, Narsicapaic. It's a super Jupiter, at least 6 times the mass of our largest planet. But what makes this world special isn't just its size, it's that we've actually seen it. James Webb directly imaged it, using a special coronagraph to block out its host star's blinding light. That's like trying to spot a firefly next to a lighthouse from thousands of miles away. Webb pulled it off. Narsicapaic is about 100 times farther from its star than Earth is from the Sun, which made it just distant enough to photograph. What Webb saw was a glowing, lonely planet with swirling heat and atmospheric features we're only beginning to understand. It was a technological triumph and a glimpse into what else we might someday capture. But not every planet brings good news. In fact, 2 promising worlds around a nearby star may have just dashed our hopes. TRAPPIST-1's disappointing atmosphere. TRAPPIST-1 is a red dwarf star with 7 rocky planets, 3 of which are in the habitable zone. Astronomers have dreamed of life here for years, but Webb's infrared instruments just gave us a harsh reality check. It looked at 2 of the inner planets and found nothing. No methane, no hydrogen, no real atmosphere at all. One of them is almost completely black, absorbing most of the light it gets, and its surface reaches 230 degrees Celsius. The second one, once thought to be a Venus twin, clocks in at 100 degrees Celsius, but also seems to lack a protective atmosphere. That doesn't mean the outer TRAPPIST-1 planets are doomed, but it's a sobering reminder that habitability is more than just distance from a star. Without atmospheres, even perfect orbits won't save you. From ancient black holes to rock rain, and from baby galaxies to possible signs of life, Webb has delivered more in 2 years than we expected in 10. And the best part? It's just getting started. So, what do you think it'll find next? Let us know in the comments below. Thanks for watching, and we'll see you in the next one.